Liz. Today we're going to go over the Excel column to number problem. We're going to use the umpire method. And if you haven't solved this problem yet, go ahead and just take a whack at it and see what you can do. If you get stuck, come back to the video. But if you can solve it, what I want you to do is compare your problem-solving process with our problem-solving process and just see where the two differ or if they're basically the same. Very first thing that we need to do in the umpire problem-solving method is understand the prompt. The prompt is, given a column title as it appears in an Excel sheet, return its corresponding column number. So let's look into this. What is it that we're trying to do in the middle? What's our key action and what's our output? So our key action is to return something, right? So in the middle, that's what we're doing. We're returning. We're not counting. We're not discovering. We're not finding. We are returning a transformation. What are we returning? Well, we're returning a number. The corresponding column number. So that's going to be a number that we're giving back. And then what are we taking in? Well, given a column title as it appears in an Excel sheet. Alright, so we've got to think about all the different types of columns maybe that we've seen in an Excel sheet. If you've seen Excel, you may know that A, B, and C are the first three columns. But what you might not have seen is an Excel sheet with longer than 26 columns. If you go past column Z, what happens is you loop back around to A again, but with 2 digits this time. So there's AA, which then advances to AB. We can kind of think of this as a base 26 number, right? Because each letter in its corresponding place value allows us to get a number out that's the same each time. So if we want to think about, okay, place values and how do we deal with that? Well, let's think decimals. We're familiar with decimals. We got 10 fingers, so we're all kind of used to decimals, right? But we know that if you have a number like 27, well, that's actually 20 plus 7, right? If you break that down. Or if you have, 2,389, that's actually 2,000 plus 300 plus 80 plus 9, right? Each digit actually means a whole number here, a whole group number, right? And when we add these all together, we can combine these numbers into one single number. So if we think about A, or like, B, C, B, D, F, right? So B, it's actually B, or 2, and then D is 4, and then F, A, B, C, D, E, F, that's 6, okay. So we've actually got 2, 4, and 6, but it's not 200, right? It's actually 2 times 26 to the power of wherever it is, right? So this is the 0th, this is the first, D, and this is the second. So 26 to the power of 2. And then this is times 26 to the power of 1. And then this is 26 to the power of 0. This is kind of how you express it in Python. This is the power of. So let's kind of see, okay, let's go with, what is 26 to the power of 2? Well, it's 676. Wow, that's a big number. What is 26 to the power of 1? Okay, it's 26. What is 26 to the power of 0? Oops, that's 26 times 1. Let's look at 26 times to the power of 1. It's 26. It's basically just like times 1. What is it times 0? Well, or to the power of 0? Well, any number to the power of 0 is really just 1. So if we translate this 26 to the power of 1, that's actually just 1. Now 26 to the power of 1, that's actually just 26. But this 26 to the power of 2, well, that's 676. So then BDF is 676 plus 26 plus 1. And then we want to multiply those here. So let's do this. Let's figure out what's 2 times 676. All right, 1352. 4 times 26 is 104. And 6 times 1 is 6. So we can kind of replace those numbers here. And then 104. Here, we're just doing some calculations, and then 6. So if we add all those numbers together, 1352 plus 104 plus 6, what we get is 1462. So BDF equals 1462. Does that make sense? Maybe. Well, let's kind of dig in here and see, okay, what was the operation here that we did? Let's get back to our 26 to the power of 2, and then this was 26 to the power of 1, and then this was 26 to the power of 0. So we've written out our calculation line by line here, and we can kind of see what happens. Well, the F is the furthest right number. So that's kind of what happens to the furthest right number, is it's 26 to the power of 0. Then if we go left by 1 to D, we're 26 to the power of 1. And if we go to B, we're 26 to the power of 2. So what we've got here clearly is some kind of loop. We're going to be doing the same set of calculations each time. But we need to start at 2 and end at 0, or start at the highest count of how long the string is, and then go down. And then there's something else happening here. Well, we're translating this B into a 2, and we're translating this D into a 4. Now, that's pretty stable. We know that D is the 4th letter and F's the 6th letter, so we know that there's just a straight translation between the sequence of letters. So how do we get that number out? Well, there's a function called ORD, and that basically just takes one letter at a time and turns it into a number. Let's look what happens when we call ORD. We pass in A. Get 65. Let's try it again and pass in B. You can see down here in my screen, we get a 66. And then C, 67. Okay, now what we want is 1, 2, and 3. And there's a difference that's stable here. 65 minus 64 is 1, 66 minus 64 is 2, and 67 minus 64 is 3. So we can make this translation happen without a whole lot of calculation. What I'm going to do is I'm just going to say, okay, what would happen if we just passed ORD, if we just passed, the column into our ordinal function? What we would get is that number out, and then what if we subtracted 64? We've kind of got a stable transformation there, right? So I'm going to comment these out so that I can run my code and just check to see that the very first part of this problem is working. If you've never used the ORD function before, that's why we're showing it to you now. This is so that later in the future, when you're working on any other problem that's similar, you can match back to this time where you learned about ORD and you learned that it translates individual characters into their ASCII values. Okay, so I'm going to just call Excel to column number here so that I can experiment with it. In a whiteboarding interview, you wouldn't really be able to do this. But while you're solving problems, especially for the first time, don't worry to try to figure it out in your head. Use Replit, that's what it's there for. Okay, so Excel to column number, we'll call A. I'll go A, B, and C. here. I like to use copy paste rather than typing things out. Okay. Cool. Sometimes that happens. All right, I'm not getting any output. Well, that's because what we're doing here is returning. So what we need to do is print. Okay, so now I can really see. Okay, 1, 2, and 3. That is exactly what I wanted it to have happen. Perfect. But now if I wanted to kind of take this and check, you know, a 2 column 1, A, B is not going to return it. It throws an error. And the reason is ORD expects a character but got a string of length 2. Now, ORD doesn't know what you want to do with a string of length 2. You could be multiplying the values by 26 in the power of their place value, or you could be adding those values together. There's all kinds of things you could do here, and so if ORD made a guess, it would probably be wrong most of the time, which is why ORD doesn't do that. It just says, hey, give me one character, or I'm throwing an error. What we need to do is figure out how to translate this sequence, ABC, into 3 different characters and know where in the string are they, right? This one is the largest multiplier. The first value, A here, is like this B here. B, right, was 26 to the power of 2. D was 26 to the power of 1. So somehow we need to know that information, where is its position, and we need to know what is its character value. We figured out how to get the character value here, and then we tested it. So we've solved get the character value properly. So here's what I want to do is I want to look at each letter individually. Now, let me think about how I might do that. So I'm just going to write in pseudocode here. For every letter in the string, starting with the leftmost, yeah, that's left, oh no, this is right, sorry, don't know my left from my right, rightmost letter. And then once I have each individual letter, for every letter in the string and its position in the string, right? What I need to do is convert the letter into a numerical value. And then you may have noticed this says connecting to server. If you've ever had this problem, what I like to do is copy this, the whole thing, and then hit refresh. And then if your code gets eaten, you still have it. Let's see. Convert the letter into a numerical value. Then what we did down here was B became 2 and D became 4, so that's the numerical value. Then we multiply the letter's value by 26 to the power of its position, starting left or right most. Okay. And then at the very end, what we do is add the value of the above value to the total. So add the above value to the total. Okay, so I figured out I'm going to need a loop. I'm going to loop over every letter in the string and its position within the string, starting with the rightmost letter. So I need 2 things here. I need every letter in the string and its position. And the other thing that I need to do is I need to turn the string around. I don't want to start with the highest value because then I'll have to count down, right? So really I'd rather count up. It's easier to count up, especially if we're thinking in position, right?